Assalamu alaikum and welcome, my dear subscribers, followers, students, colleagues, ladies and gentlemen. Today I'm going to explain a different type of game which is known as uh, game of coexistence, and it is titled as the Hawk Dow game. Uh, as the name as the name suggests, uh, this game is not between a hawk and a dove, because then the outcome will be certain, but instead it means that a single species of animals may have different type of behavior. The behavior may be like a hawk or like a dove. So be with me and kindly watch this video till the end so that you could understand games of coexistence. And let me start with the background. The theory of game is not only applicable in other disciplines like economics, political science, and so on. This theory is also applicable to zoology, biology, and the animal behavior. In recent years, biologists have come to regard game theory as an indispensable tool to study animal behavior. The most famous game of animal interaction is the hawk-dove game. But this doesn't mean that there is a game between hawk and a dove. So this doesn't refer to a game between hawks and doves, which would have a pretty predictable outcome, but rather to a game which involves a single species that exhibits two types of behavior, that is hawkish or dovish. Let us think of a wild dog. When two wild dogs come across a piece of food, they have to decide whether to fight or to share. So they have two strategies, either to fight or to share between them. Fighting is the hawkish strategy. One will win and the other one will lose. Sharing is a dovish strategy. It works well when the other player is also behaving like a dove. But if the other player is hawkish, the offer to share is rejected and the dovish player will get nothing. A possible set of payoffs is given in the following table. Now, this is a payoff game for hawk-dove game. So one pair is here, that is one wild dog is here, and one wild dog is here, whose strategies are measured row-wise, and the strategies of the another wild dog are measured in column-wise. So these are the various payoffs. So I'll explain these. If both wild dogs play dovish, they end up with a pay of 2-2. So both of them are going to have positive payoffs equal to 2. If one plays hawk and the other plays dove, the hawkish player wins everything and the dovish gets nothing. But if both play hawk, each dog will be seriously injured and both of them will be in loss. If it is obvious, it obviously cannot be in equilibrium if everyone plays hawk, since if some dog played dove, it would end up with 0 rather than -2. So, and if all dogs played dove, it would pay someone to deviate and play hawk. So there will have to be some mixture of hawk types and dove types in equilibrium. So what sort of mixture should we expect? That could be explained with the help of the following equations. Suppose that the fraction playing hawk is given by P, then a hawk will meet another hawk with probability P and meet a dove with probability of 1 minus P. The expected payoff to the hawk type will be given by the following equation. So the equation denoted by H shows the payoff of the hawkish player, and the expected payoff to the dovish wild dog is given by d is equal 2 into 1 minus p. So this is the payoff of the other player which is playing doish. Now suppose that the type that has the higher payoffs reproduces more rapidly, passing its tendency to play hawk or dove onto its offspring. So if h is greater than d, we would see the fraction of hawk types in the population increase, and if h is less than d, we would expect to see the number of dove types increase in population. The only way the population can be in equilibrium is if the payoffs to each types are the same, and this would require that h is equal to minus 2p plus 4 into 1 minus p, and that is equal to 2 into 1 minus p, and that is equal to 2. So in that case, the payoff to hawk is equal to the other player which plays dove. So this solves for p is equal to 1 by 2, that is the probability is 50-50. We have found that a 50-50 mixture of doves and hawks is in equilibrium situation in this case. Is it stable in some sense? If you know the answer, you may write your answer in the comment section below. Thank you very much for watching this video. I hope that was quite informative and useful for you. If you haven't yet subscribed to the channel, kindly subscribe this channel, and don't forget to click on the bell icon. In that way you will get notifications about my other videos that will be uploaded soon for you. Thanks for watching this video. Kindly subscribe the channel and share its various videos in various WhatsApp groups. You may also share this channel and various videos of this channel with your friends, with your colleagues, with your students, so that they can get